Motion under gravity. Uniformly accelerated motion. Before we begin, let us recapitulate. This is an acceleration time graph for zero acceleration. That means when the body is moving with uniform velocity or the body is at rest. We see that the graph line is a straight line coinciding with the time axis. This again is an acceleration time graph for uniform acceleration. Here the graph line is parallel to the time axis and it is lying on the positive side of y-axis. Next, acceleration time graph for uniform retardation. Here the graph line is again parallel to the time axis and it is lying on the negative side of the y-axis. Now one more thing. In case the body has velocity which is changing in an irregular manner, the acceleration will be variable. That means the acceleration time. Let us begin. Motion under gravity. This is a graph for a freely falling body. Here we have taken acceleration due to gravity as 10 meter per second square. The area will give velocity in different intervals of time. Now, velocity when time is equal to 0 is equal to area of rectangle whose base is 0, that is equal to OA into 0. You have to imagine a rectangle whose base is 0. We have 5 meter per second square into 0 second, that is 0 meter per second. Next, velocity after 1 second, that is area of OABP, that is 10 into 1, that is 10 meter per second. Velocity after 2 seconds, that is area of OACQ, that is 10 into 2, 20 meter per second. Next, velocity after 3 seconds, area of OADR, that is 10 into 3, that is 30 meter per second. Next we have velocity after 4 seconds, that is area of OAES, that is 10 into 4, 40 meter per second. And velocity after 5 seconds is area of OAFT, that is 10 into 5, 50 meter per second. Now, the data we have collected. From this, let's see the velocity time graph. Here we have velocity time graph, as you can see. Now the displacement time graph can be calculated from this VT graph by finding the area. First, displacement when time is equal to 0. Imagine area of triangle at the origin. The base of the triangle is 0 second and height is 0 meter per second. So we'll get, on finding the area, 0 meter. Next, displacement in 1 second, that is area of triangle OAP, that is half into 1 second into 10 meter per second, that is 5 meter. Displacement in 2 seconds, area of triangle OBQ, that is half into 2 into 20, that is 20 meter per second. And displacement in 3 seconds is equal to area of triangle OCR, that is half into 3 into 30, is equal to 45 meter. And displacement in 4 seconds is equal to area of triangle ODS, that is half into 4 into 40, that is 80 meter. And displacement in 5 seconds is area of triangle OET, that is half into 5 into 50, that is 125 meter. So here we have the displacement time graph. You can see in the figure. We will now see that the displacement is directly proportional to square of the time. S is proportional to t square. The data we have collected is shown here. And here we have the graph. displacement versus square of time. The unit on y-axis is meter and the unit on x-axis is second square. Now the slope of this graph, I am taking the whole line. You can take any section of it, you will get the same value as it is a straight line. So we have 125 minus 0 meter divided by 25 minus 0 second square, that is 5 meter per second square. Here the value is half of the acceleration due to gravity. So we see the value of acceleration due to gravity can be obtained by doubling the slope of s versus t square graph for a freely falling body. Now that's all for today. We'll meet again very soon.